Welcome humans. Sit down, grab your notebooks, and prepare your whiskers, brains, for another mind-bending lecture by yours truly, Professor Max Purwell, the world's leading and only feline physicist. Today we'll dive into the weird, wild world of quantum materials, a topic so strange it makes my obsession with sitting inside shoeboxes look perfectly normal. Let's start with a story. Imagine you're a cat, because being a cat is awesome, obviously, and you're staring at a pair of sneakers. But wait, these aren't normal sneakers. Oh no, these are quantum sneakers. They have magical properties. On the surface, they look simple. Laces, soles, maybe a Nike swoosh. But in reality, they're made of quantum materials, substances with bizarre properties governed by the rules of quantum mechanics. Now here's the fun part. Schrodinger's sneakers can do weird things. When you're not looking, the left sneaker is both tied and untied at the same time. But as soon as you peek, boom! The sneaker chooses its state, just like Schrodinger's infamous cat choosing whether to be alive or dead. Don't blame the sneakers. It's the quantum particles inside them. They thrive on chaos. But Professor Max, you ask, why are these materials so strange? Excellent question, hypothetical student. The answer lies in their quantum nature. You see, quantum materials are made of particles that don't play by the same rules as everyday stuff, like wood, metal, or Barkley the dog's chew toys. No, these particles live in the world of superposition, entanglement, and quantum weirdness. Basically, they're like me at 3 a.m., completely unpredictable. One type of quantum material is called a superconductor. Imagine a tiny mouse running down a hallway. Normally, the mouse has to dodge obstacles, cheese, mouse traps, and maybe Barkley napping in the corner. But in a superconductor, the hallway is perfectly clear, no obstacles. The mouse zips through without slowing down. That's what happens to electricity in a superconductor. It flows with zero resistance. Why does this matter? Well, imagine your phone battery lasted forever, or trains that could levitate and move super fast. That's what superconductors could do. Unfortunately, there's a catch. They only work at super cold temperatures, like minus 200 degrees Celsius. So unless you enjoy living in an ice cube, we're still working on making them more practical. Next up, topological insulators. Sounds fancy, right? Like something you'd order at a five-star restaurant. These materials are weird because they're insulators on the inside. Electricity doesn't flow through them, but their surface is like a dance floor for electrons. Those electrons boogie-woogie around the edges in perfect harmony, like they're at an electron disco. Why do we care? Well, those dancing electrons are super stable. They could be used in future quantum computers to store data that doesn't get scrambled, unlike my brain when someone moves my food dish. Let's talk about quantum spin liquids, a material that sounds like it came straight out of a sci-fi movie. Normal magnets are orderly, like Barkley staring at his food bowl. But quantum spin liquids? They're chaotic. The tiny magnetic particles inside, called spins, refuse to line up neatly. Instead, they swirl around each other in an eternal dance, like a kitten chasing its tail forever. What's the point of these materials? They could revolutionize data storage. Imagine storing every cat video ever made on a single quantum hard drive. Yes, even the one where the kitten rides a Roomba in a shark costume. But Professor Max, you ask, why do we care about quantum materials? Can't we just use normal stuff like steel and plastic? My sweet summer kitten, you're thinking too small. Quantum materials are the superheroes of the material world. They can make computers faster than a laser pointer in a room full of cats, create power grids with no energy loss. Take that, electricity bill. Help build quantum computers that solve problems classical computers can't even dream of. In short, quantum materials are the future. They're weird, they're wonderful, and they're just getting started. Now, if you'll excuse me, I have a quantum experiment to conduct. It involves photons, lasers, and, if all goes well, a treat dispenser that only opens for me. But remember, students, quantum materials may sound strange, but they hold the keys to a future so advanced it makes my laser pointer look like a caveman stick. Class dismissed, and don't forget to close the lid on Schrodinger's sneakers. You wouldn't want to collapse their quantum state too soon.